Welcome to this intro lesson on constructions. We are going to use two tools to do constructions. We use a compass and we use a straight edge. And these tools are used to make two very basic geometric objects. A compass makes points on a circle, and a straight edge makes points on a straight line. Straight edge should be pretty easy to imagine. You might use a ruler. You might use something that is straight on an edge, but it's not a ruler. Like this side doesn't have any numbers, doesn't matter. All I need is the ability to draw a straight line. Or a line segment, because this is starting and stopping. And everywhere along this line segment there are points. There are points there, there's a point there, there are points everywhere on here. Everything you see made of pencil is a point. If there's a point that is special for some reason and you want to highlight it, you might kind of bold it and make it stick out more than the others. And now I know this is a special point that I'm going to use for something. But everything you see on here is a point. A compass looks like this. And there are other types, but I'm going to use one that looks like this in these videos. You pin the center of it and then this part spins and you put your pencil in one of the openings. You can adjust where the openings are, and when you use this tool you end up making a circle. A circle starts with a center point, and then a circle consists of points that are all the same distance from the center. And our word to describe that distance, of course, is radius. So we're going to use these two tools to do some basic constructions, and in future videos we're going to do some more complicated ones. The first construction we're going to do is copy a line segment. When you copy a line segment, you start with the original. You make a copy. Those copies are the same, and a slightly fancier geometric word we would use for same is to say that the original and the copy are congruent to each other. I'm going to demonstrate freehand how to do the construction on the left, and this is what should go in your notes. And then on the right, I'll use a compass and straight edge to actually do the construction, and you could follow along if you have one. Otherwise, you can just watch this part, but the stuff on the left is what goes in your notes. So when you start with an original line segment, something that looks like this, you want to measure how big this segment is, and you want to copy it and put it over here. And there are a couple ways you could do that. The first is you make another line segment that is longer, and then you take your compass, you pin it to one side, you open it up to see how long this is. You would put a little arc here in order to make sure that you actually set your compass to be the right distance. And then once your compass is set, you would just slide it down over here, set it down on the left side of this segment, don't adjust anything, put your pencil back in the compass and make a mark. And when you make that mark, this distance and this distance, they are the same. And so this segment and this segment would be copies of each other. And in order to show that they're copies of each other, you would put a little tick mark here and a little tick mark here, and that means this and this are the same. You don't have to start on the left side. You could measure how big this segment is, draw some other random segment, come down over here, flip yourself around, pin the compass to the right side, put an arc. So I'd pin the compass on this side, I'd put an arc. There's the arc. Now I know this segment right here is the same as the two that came before it. Or the other option is you start with your random segment, you measure how big this segment is, you come down here, you pick some random point on the segment, I'll pick right there, center myself on that point, make an arc, and now this segment right here is congruent to this one, and it's congruent to this one, and it's congruent to this one, and they're all copies of each other. So here's what it looks like with a compass. Start with some segment, and I want to make a copy of it. So the segment I copy onto does not have to look parallel to this. It doesn't have to go in the same direction. It could be some crooked piece, doesn't matter. I take my compass, put the turning point on one end, pin it, open this slider part so that the opening there is lined up with the end of the segment. I'll put a little arc, go away, that was perfect. This was exactly the distance I need it to be. So now I can come over here, pin myself on the left side, put an arc, and now this segment and this segment are the same. Or, keeping this fixed, I don't want to change the size, I know I measured it correctly. I could come and pin myself on the right side and put an arc. And now this is the same as this, is the same as this. Or I could pick some point somewhere inside the segment, come over here, center myself on that point, put an arc, and now this segment is the same as this segment, is the same as this segment, is the same as this segment. And when you've done a construction, you should leave these marks on here, because these marks, this arc, this arc, this arc, this arc, this point you've highlighted, this is how you communicate to someone that you actually did the construction and you didn't just sketch something freehand that's close but not perfect. The next construction we're going to do is one where we copy a triangle. And this is really just the same as doing the line segment copy 3 times. Triangles have 3 sides. We want to copy those 3 sides, and when we copy those 3 sides, we'll have copied the triangle. So you start out with some triangle. You pick one of the sides to start with. I'll pick the bottom side. You don't have to, you could pick any of them, but I'll pick the bottom side. I would take my compass, pin it on this end, put the center here, open up so that I'm measuring this distance, the length of this bottom segment here. And then I would come down, create a new segment. Doesn't have to be facing in the same way. It could be crooked and kind of pointing in a different direction. I would measure this. I would come down over here. I would put an arc, put the exact same arc, and now I know this segment and this segment are copies of each other. Then I would come back to the original and measure a different segment. Like I would come over and measure this segment now. So I would pin myself to this corner, adjust the compass so that I'm measuring this new side, lock it, come down over here, and put an arc. And when I put this arc, I'm going to make it kind of a big arc, because as you'll see in the next step, I'm not exactly sure where the intersection is going to take place, and I want to give myself a big arc to make sure that I create an intersection, and you'll see what that looks like. So I set the compass, I come down over here, I put some big arc. Then I come back to the original and I measure the third side. So I have to readjust the compass, pin myself in this vertex, open the compass up to be this length, bring it down over here, pin myself to that point, because that point matches with that one, and I had this distance measured. I come over here, I put an arc, something like that, and right there, that point matches with that point, and I would take my straight edge and sketch in the rest of the triangle. This side matches with that one, this side would match with that one. I'm going to put different marks because this matches with this and this matches with this. The third side, pair of sides, those match with each other, so I'll put 3 marks. With the compass, here's what it looks like. I'll make some random triangle. I'm going to start with this bottom side. So I'll pin myself to that vertex, open up to measure that side, check to make sure, yep, That looks good. So I'll come down here, make some random segment. I'm going to take this side, and I'm going to put it right there. So I pin this, put an arc, and now I know this side and this side match with each other. I'm going to come back to the original. I'm going to measure a different side. I'll measure this one. Pin myself at that vertex, adjust the compass. That looks good. Make an arc. Yep, that's set to the right length. Bring it down over here and put an arc. Now I need to measure this last side. So I set the compass turning point right there. Adjust the opening. That looks good. It looks a little long. I'm going to slide it in a tiny bit. A little more. There, that looks good. Bring it over here, pin myself to this point, because this point corresponds with that one. Make an arc. And now I can connect my important points. I can connect the end of this segment to that intersection, and that intersection over to this point. And when I do that, this matches with this side matches with this side matches with that side. The last construction we're going to do here is one where we copy an angle. And copying an angle is exactly the same as copying a triangle. Sort of. It's actually a little easier, but I think it's good to think about it as being similar to doing the triangle copy. So here's what this looks like. You start out with some angle. Here's the angle. I want to make a copy of this angle. Even though it's not drawn into the picture yet, I could turn this picture into a triangle. I could, let's look at this edge right here. I could make a triangle. I could make that triangle. I could make that triangle. I could make this triangle. There are infinitely many triangles that I could make. I'm going to make the easiest triangle I can make, which is one where the length over here is the same as the length over here. So it's an isosceles triangle. This side will be the same as this side. I will pin my compass to this vertex, open up to some distance. It doesn't matter how far you open up, as long as when you make your arc, you end up hitting both sides of the angle. If I wanted to, I could sketch a triangle in here. I'm not actually going to do that, but I could imagine that there is a triangle here, where this side is the same as this side. When I come down to make my copy now, I'm going to start with some random segment. I'm going to pin myself to this vertex, to this end here, and whatever distance I had, I just keep it and put the exact same arc, because I'm trying to copy this side and I'm trying to copy this side. So I set this arc, I bring it down over here, I make the exact same arc. It looks something like that. Then, just like in the triangle copy, I go and measure another side. I'm not going to measure this side because I already measured it. It's the same as the first one. This one and this one are the same distance. So this one and this one are the same distance. I don't know where this one should exactly land, but the way I'm going to find it is to measure this distance. So I would reset my compass to be centered here, open it up by some amount, come down over here, make an arc. This intersection here corresponds to that point right there. So I would then connect this endpoint to that point and end up making a copy of the angle. This hidden side, you could imagine that it's there, even though you don't need to draw on it, it's not part of the construction. you could imagine that it's there. So here's what that actually looks like. I start with some random angle. I set my compass to be some distance. If I opened it this far, that would be too much because I wouldn't end up hitting that side. So I'll set it there. Make an arc. Come down over here. Put some random segment. I'm going to take this distance and bring it down over here. So this has been set already. I come down here, pin this to the end of the segment, make an arc. There's this imagined triangle that I'm not actually putting in the picture, but I can visualize it there. I'm going to measure this distance. Pin myself to that point. Readjust this. Let's see. That looks good. Yep, perfect. Come down over here. I started with the turning point here. I'm going to put the turning point right there. Make an arc. This intersection point is important to me, so I'm going to highlight it, bold it. It's the same corresponding to this. So now I can connect that intersection to this endpoint, and I have made a copy of this angle. To check myself, if you happen to have this type of compass, you're in luck because this part of it is another tool called a protractor. A protractor is used to measure angles. You see there's a 0 on it and then it counts 10, 20, 30, 40, 50, 60 and so on, and you can measure angles. I want to check my work. This isn't how you do the construction, this is how you check the construction. You set the center of the turning point to be at the vertex, you adjust the 0 so that it is lined up with one of the sides, and you measure how big your angle is. This looks like 10, 20, 35 degrees. So this is, it's about 35 degrees. I'm going to check this one. Put the center at that vertex, line up the 0 with one of the sides, 10, 20, 35. Yep. This is also about 35 degrees. I know my construction's good.